All right, this is your warm-up for your Unit 1 Quiz 2. It's on page 51. So you should be on page 51 looking at this warm-up. This is a warm-up you should do yourself, and then I will go over it. So if you have not had a moment as a class to do that, then I'm going to recommend about 10 minutes for this. And you can pause the video for those 10 minutes, do the warm-up, and when you unpause, I'll go over it. Pause. All right, and if you're watching now, then you have unpaused the video because you have finished the warm-up. You've taken your 10 or so minutes to finish it. And let's talk about it. Number 1, which of water, iron, ammonia, chromium, radon, and silicon are chemical compounds and not elements? Remember that we can always identify an element because it will be on the periodic table. So all you really need to do is find if any of these exist on the periodic table. Now I will point out that water, you should probably already know, is H2O. And since we've got 2 capital letters there, that tells me there are 2 elements. And therefore this must be a compound because you have 2 elements together. So water is definitely a compound, and that means any of the answer choices that do not have water, we can definitely rule out. From there, though, we're going to have to look on the periodic table and see if we can find any of these others. Iron is an element. It's number 26. It's got symbol Fe. If you keep looking, chromium is also an element. It's number 24, symbol Cr. Radon is an element. It's number 86, symbol Rn. And silicon is an element. It's number 14, symbol Si. But no matter how long or hard you look, you're not going to find ammonia on the periodic table because it is not an element. It is a compound. And really, if you look at these other answer choices, once we found chromium, we knew it couldn't be A. We had already ruled out C and E. So then it just came down to, can you find ammonia on the periodic table or not? And you cannot, which means it's not an element. It must be a compound. So D is our correct answer here. Number 2, an example of a heterogeneous mixture is gold, concrete, brass, or water. Again, we've already talked about water. It's a compound. Compounds are pure substances, which are the opposite, basically, of mixtures. So it's definitely not a mixture. Gold, also, is a pretty obvious one. It's on the periodic table. It's an element, which is also a pure substance, and therefore definitely not a mixture. It can only be one or the other, a pure substance or a mixture. Can't be both. That leaves us with concrete and brass. We talked about brass in one of my other videos. Brass is an alloy. And if we go back to our notes about the classification of matter on page 45, we talked about alloys. I mentioned that steel, brass, and bronze were all alloys, and we talked about how alloys are homogeneous mixtures. They are well mixed. So that rules out brass, since the question asked for heterogeneous mixtures. And if we think about it, it makes sense that concrete would be a heterogeneous mixture. If you look at concrete, you can see visible differences with your naked eye. Like there are some specks of it that are kind of glittery, shiny. Sometimes you can see pebbles stuck inside of it. Concrete is not well mixed. It is a heterogeneous mixture. Let's look at number 3. How is a mixture different from a compound? Remember, first of all, that a compound is a type of pure substance, and a mixture is when you have pure substances that have been mixed physically with each other. So let's keep that in mind. Particles of a mixture are combined chemically. Components of a mixture can only be separated chemically. Components of a mixture can be separated by physical means, and composition of a mixture may be constant. If we look back at our notes about mixtures, back on page 45, our notes said that they have to be physically combined and physically separated. So that right there knocks out A, saying chemically combined, and B, saying separated chemically. That leaves us with C, which is looking like a pretty good answer choice, or possibly D, composition of a mixture may be constant. But if we look at our notes, I don't see anything about constant on either pure substance or mixture. We're going to have to think about what that word constant means to decide which set of our notes actually was talking about it. Composition being constant, that means that the composition is like composition being like what it's made of. First of all, let's make sure we know that word. What a mixture is made of may be constant, meaning all the same. And remember, the point of a mixture is that you have two or more different substances. They are not the same as each other. So mixtures should not all be the same. This answer choice is saying they are the same. This can't be correct. And that leaves us with C, which we had already thought, that's a pretty good looking answer. Number 4, which words best describe a pure sample of glucose, C6H12O6? Again, right away I can see the fact that there are 3 capital letters here. That tells me these 3 capital letters all mixed together that this is a compound and not an element. If it were an element, there would only be 1 capital letter. And then from there, I have to ask myself, is a compound the same thing as a heterogeneous mixture? Is a compound a pure substance? And again, we can look back at our notes on page 45. Heterogeneous mixtures are a type of mixture, which are a type of matter, but different from pure substances. However, a compound is a type of pure substance. So a compound is not a heterogeneous mixture. It is a pure substance, though. So we need the answer choice that has both Roman numeral 1 and 4, which is answer choice D. Okay, let's look at this bottom section. We have to look at some properties and decide if they're physical or chemical, intensive or extensive. Remember, physical properties is you can observe or measure without the substance identity changing. Whereas a chemical property, the identity will change. Intensive and extensive are different. They're about how much stuff is there. Intensive properties are independent. Intensive is independent of the amount. Doesn't matter how much stuff you have, it's still going to have that property. Extensive depends how much you have. So let's take a look. The mass of a cup of water is 50 grams. First of all, physical or chemical, can I measure a mass without changing what the stuff is? If you think about it, measuring a mass just means you're sticking it on a scale. Does it continue to be a cup of water if you stick it on a scale? Yeah, That doesn't change its identity. That's going to be a physical change. But when we come to intensive extensive, we're not thinking about its identity anymore. We're thinking of how much stuff it has. If I had a different amount of stuff, would it still be 50 grams? And the answer is no. It would not still be 50 grams if I had a different amount of stuff. It might be only 45 grams, or it might be 100 grams. So the mass depends on how much stuff I have. That means that that mass is an extensive property. The chemistry booklets are orange. First of all, can I observe that they're orange without changing what they are? Or does the fact that I looked at it and said, hey, it's orange, change what it's made out of? It continues to be a book. Just because I've noticed it's orange doesn't make it stop being a book. So that means this is a physical property. And then for intensive or extensive, doesn't matter how much book I have. If I have the entire cover versus if I just tear off a tiny piece of the cover, does it stop being orange, or does it change the fact that it's orange? And the answer is no. That the orangeness is independent of how much of the book I have or how much of the cover I have. It doesn't matter how much of the cover I have, it's still going to be orange. That makes this an independent property. Arsenic is very toxic. If I observe that it's toxic, has the identity of the arsenic changed? And we talked about with toxicity, if something is toxic, that means that it is changing your cells, and your cells stop working the way they were supposed to, and they're converting the arsenic into something else. So you are seeing identity changes when you have something be toxic. That's a chemical property. But does it depend how much arsenic I have? Is the arsenic going to continue being toxic no matter if I have a drop or if I have a whole bottle? Yeah, it's going to continue to be toxic no matter how much I have. It's independent of the amount that's intensive. Gold is very malleable. This word malleable means that you can hit it with a hammer and reshape it however you want. Does it stop being gold just because I put a dent in it when I hit it with a hammer? Does it change into something besides gold, or does it continue to be gold? If it continues to be gold, then that's a physical property. And will the fact that gold is malleable depend on how much I have? If I have a whole bunch of gold, like a brick, versus if I have a tiny little nugget of gold, is that going to change whether or not the gold can be reshaped? And the answer is no, it doesn't matter how much gold I have. A little nugget is just as malleable as a giant brick of it. It's independent of how much I have. That's an intensive property. And our last one, uranium, is very radioactive. Radioactivity is a type of decomposition. When something is putting out radiation, it is decomposing, which means it is changing from uranium into something else. Its identity changes. That's a chemical change. And the fact that it's radioactive, is that going to matter if I have a tiny bit of uranium or a whole, power plant's worth? No. The fact that it's radioactive is going to always be a fact, no matter how much of it I have. It's independent of the amount. That's an intensive property. I'll point out that extensive properties are pretty much length, mass, and volume, and almost everything else that we talk about ends up being an intensive property. Extensive is pretty much length, mass, volume. Basically everything else is intensive. So that's probably the easiest way to be able to answer this intensive extensive question, is if you know length, mass, and volume are extensive, then that's going to help you with most of these problems. There are other extensive properties, but these are the main three. Our final section, match the substances to the type of matter. Tin, SN. If we've got this element symbol and there's only one capital letter, that tells me this is an element. When I look at CaNO3, I have 3 capital letters in this formula. There's multiple elements here, and if there are multiple elements, this must be a compound. For ice, it kind of helps if you think about what ice is. Ice is solid water. And remember that water is H2O. I'm looking at 2 capital letters, and I'm looking at a compound. That was kind of a tricky one. You have to think about what is ice before you can answer that question properly. Coffee starts as water, and then you dissolve into it some stuff that comes from coffee beans. And that already tells me it's some kind of mixture, because there's a compound water plus a bunch of other stuff. It can't be a pure substance. It must be some kind of mixture. Then you have to ask yourself, is it homogeneous or heterogeneous? If you have coffee, is the first sip going to have the same composition as the last sip? And assuming the coffee is well made, which there's nothing here to tell you it wasn't, then I would say, yeah, it's going to be the first sip and last sip are going to be the same. So this is a homogeneous mixture. It is well mixed. And the last one, pizza. I know pizza is not an element on the periodic table. I know it's not a compound because there's a bunch of different components of pizza. You got, at minimum, crust, cheese, and sauce. So it's got to, again, be some kind of mixture. And is every bite of pizza the exact same as every other bite? Even if you have cheese pizza, no, that's not true. Some bites are going to have more cheese or more sauce or more crust, which means this is a poorly mixed mixture and heterogeneous. All right, at this time, unless Miss Woodlock says otherwise, you're going to end up taking your quiz. Real quick, go back to your stamp page before you put your books away for the quiz. I definitely want to make sure that for a stamp you end up doing your test review, because at this point you should have a test next class, because today, depending on if it's an A day or a B day, today is either September 1st or September 5th. And remember, we wrote down on your calendar that your test was the 6th or 7th. So that's next class. So your test review is going to be for a stamp. It's pages 54 through 57. And Miss Woodlock may or may not have some other activities for you, depending on how quickly you take your quiz. And if she does, she is more than welcome to add those as extra stamps you will also have to do. But at minimum, your stamp page should look like this, again, unless Miss Woodlock has had a reason to change it. Good luck on your test. The next time you hear my voice, it'll be Unit 2, and I'll hand it over to Miss Woodlock.